Okay, so we're just going to quickly look at the simultaneous equations in context, because this can be something that people find kind of difficult to do. As with kind of any of the word questions, I would say those are always ones that people find difficult in any part of maths, because it's just translating from the question they're asking to the type of maths question that we need to do. So that's something we're going to look at, is just kind of from reading the question, how can we figure out exactly what the plan is here? Because obviously we know now that we're looking at simultaneous equations in context. But if you were reading these out, like if you were reading these questions just in an exam paper in the middle of everything else, how would you know that this is the sort of question you're looking at? So the main things I suppose with these questions and with any kind of word problems is we have to identify and define the variables. So we look at the question and see what's unknown, what is the unknown in the question, and can we give that a name? So we just give it a letter, something nothing fancy, just we keep it simple, we give it a letter, and then we use the relationships to construct some linear equations. So depending on how many variables we have, that's supposed to give us a hint then on how we can solve the equations. So if we have a word problem where there's two things we don't know, that might be a symbol or a signal to us that we have to use a simultaneous equation. That's kind of the idea here. So let's look at this example here and we'll talk our way through it. So at a particular cinema, there are adult and children's tickets. Adult tickets cost $8.50 and children's tickets cost $4.50. One weekend, 1,000 tickets were sold and a total of 7,300 was collected. How many adult and children's tickets were sold? So in this question, we have two things we don't know. If we let X be the number of adult tickets, and we'll maybe let Y be the number of children's tickets. Okay, we're keeping it fairly simple. We could use A and C either. It really doesn't matter what letters you use, but we're just identifying what the unknowns are. So the unknowns, or the things we're looking for, is how many of each of these types of tickets were sold. And there is a difference between them, so we can't use the same letter for both, because we know there were 1,000 tickets sold, but they want to know specifically how many of each. So we have X for the adult, Y for the children's. So that's telling us nearly straight away, right, this is probably going to be a simultaneous equation. So I'm going to have to try and come up with two equations using X and Y. So with these questions, there's nearly always, I don't want to put it as like a true for all cases, but nearly always one of our equations will just come from the context of our variables. So here, X and Y are tickets, so one of our equations is going to be to do with the number of tickets. Okay, so we have X adult tickets, we have Y children's tickets. So one of our equations is probably just going to be surrounding the number of tickets. Like that's going to be the context of that equation. The second equation here is probably going to be to do with the price and money. So the second equation will probably revolve around the price of the tickets. And the thing that kind of says this to me, I suppose, is obviously just from seeing a lot of these questions, but the things in the question that would tell me are things like this here. They tell us how many tickets were sold altogether, 1,000. That's an answer for me. That's something I can put equal to 1,000. If I was to add up the number of tickets, I would get 1,000. The same thing with this amount of money here. If I was to add up the amount of money I make from each of these types of tickets, the answer is 7,300. Okay, because we know for the first equation it's going to be equal to 1,000. The second one is going to be equal to 7,300. So let's try and make up these equations. Okay, so for my first equation, the number of adult tickets plus the number of children's tickets is 1,000. So when I add up each of the types of tickets, however many tickets I got from both of them, the answer is 1,000. If I do the same thing now with the price of an adult ticket was 8.50. So if I multiply that by however many tickets there were, and if I do the price of the children's one and multiply that by however many children's ones there were, my answer should be 7,300. So if I had 10 children's ones, then I make €45. If I have 20 children's ones, then I make €9, €90. Okay, so following through in that way. So these are my two equations now that I'm going to be solving. So let's multiply this top one maybe by minus 4.5, and we'll try and eliminate the y part. So that's going to give me, let me see, I'm a little slow today. 4.5 by 1,000, I should be able to do that. I'm just going to say nothing. 8.5x plus 4.5y equals 7,300. So I get 4x being equal to, again, I'm just going to do it on the calculator to save myself making a mistake, 2,800, which gives me that x is 700. Give me that x is 700. Okay, so x is 700, that's the number of adult tickets. We know x plus y is 1,000. So 700 plus y is 1,000, which means that y is 300. So let's just make a little note here then as well. So the adult tickets, we had 700. The children's, we had 300. Okay, so that's our general idea that we're going to be following with all of these questions, and it doesn't matter whether it's 2 variables, 3 variables, that kind of reveals itself to us as we go through the questions. So let's look at another example. A cafe sells a small coffee for €3, medium for €4, and large for €5. So this is immediately saying to me, right, 3 variables. I have 3 different things that they're pointing out to us. One morning they sell 30 coffees. So we've been given a total. We've been given a total number of coffees. That's probably going to be an answer to one of our equations. Earning a total of €110. Again, a total. If they sold 4 more medium coffees than small coffees, how many of each coffee did they sell? So how many of each coffee did they sell? So let's let x be the number of small, let's let y be the number of medium, and let's let z be the number of large. So these are my three variables at this time. So x is the number of small, y is the number of medium, z is the number of large. My first equation is going to be the number of coffees. So my first equation is probably going to be to do with the number of coffees because I know that that was equal to 30. My second equation is going to be to do with the price of each of those coffees because I know that at the end of the day I made €110. So I have to figure out what the equation is, but I know the answer is 110. The last equation now, because we're doing a 3 variable one, we should have 3 equations. The last equation is going to come from this last line. They sold 4 more medium coffees than small coffees. Okay, so the number of medium coffees is the number of small coffees plus 4. And you could do it the opposite way around. You could say the small coffees is the medium, take away 4. But they sold 4 more medium than small. So this is our last equation, and we can maybe rewrite that one a little bit in a second. Okay, so let's focus on the first equation first. The number of coffees was 30, so x plus y plus z should be 30. The second one then was to do with the price, so 3x plus 4y plus 5z should be €110. So multiplying the price by however many coffees there were sold at that price. And the last one I'm just going to get by rearranging it a little bit. So x minus y is equal to minus 4. So if we focus on our first 2 equations, let's just look at those and we're going to try and eliminate z, and that will allow us then to use our last equation. So let's multiply the top one by minus 5. Minus 5x minus 5y minus 5z equals minus 150. 3x plus 4y plus 5z equals 110. So let's have a look then. Minus 2x minus y equals minus 40. Okay, minus 2x minus y equals minus 40. So let's take these 2 equations now. X minus y equals minus 4, minus 2x minus y equals minus 40. Let's multiply this one by minus 1. No harm to just get rid of the minuses altogether. So 2x plus y equals 40. And I'm going to get that 3x is equal to 36, which would mean that x is equal to 12. We know that x minus y is minus 4, so 12 minus y is minus 4. And if I move things over and simplify, I get a value of y of 16. And subbing back in, I'm going to take it over here. X plus y plus z equals 30. So subbing in my values here, I get 12 plus 16 plus z equals 30, which gives me that z is equal to 2, so only 2 large coffees. So again, I'm just going to write these down. X is 12, y is 16, z is 2. I mark them in. So again, the same idea. Okay, we read through our question, we see how we can compose these equations, and then we just proceed to solve them as we've done already. Let's just look at one more example here, again an exam style question. James ordered 200 flowers for a wedding reception. He ordered carnations, roses and daisies, and we have prices for those. He ordered 20 fewer roses than daisies. The total came to this. How many of each type of flower? So let's use the letters that we have this time. So carnations, roses, daisies. Okay, fairly straightforward. Our first equation is going to be just to do with the number of flowers, because we have an answer for that, because we know that that is equal to 200, because that's however many he ordered. The second equation is going to be to do with the price, because we're told that the total there is 589.50. And my third equation then comes from the last line, and that's going to be 20 fewer roses than daisies. He ordered 20 fewer roses than daisies. So the roses he ordered was daisies, take away 20. So let's put our equations together. Carnations plus roses plus daisies is 200. The prices then, 150 carnations plus 575 roses plus 260 daisies is 589.50. And then my last equation, we can simplify, d minus or equals 20. D minus or equals 20, or minus or plus d equals 20. It doesn't really matter. Okay, so let's just take the first equation first of all, I suppose. So c plus or plus d equals 200. 1.5c plus 5.75 or plus 2.6d equals 589.50. Let's pick one of our letters. We're going to have to get rid of c, because c doesn't appear in the last equation there. So let's go with that. Minus 1.5 or minus 1.5d equals, let's see, 200 by 1.5 is 300. So minus 300. 1.5c plus 5.75 or plus 2.6d equals 589.50. Okay, and as with the other equations, at this point it's just a matter of solving. Okay, it's just a matter of solving them out. So we get 4.25 or plus, that should be 1.5d there, which is going to give me 1.1d, and over here we get 289.50. I can take my other equation here then, minus or plus d equals 20. Okay, and I'm going to multiply by 4.25 here on the bottom, just to eliminate or, because it's already a minus. 1.1d, 289.50 minus 4.25 or plus 4.25d, 20 by 4.25 is 85. Okay, and simplifying down, that's going to give me 5.35d equals 289.50 plus 85 gives me 374.50. And if we divide that by my 5.35, we get a number of 70 daisies. 70 daisies. Now we can take that and sub it into one of these equations. As before, we get that the roses is minus 50. So roses is 50. And we knew then that all of my flowers added up to be 200. So adding in the ones that we have already, we get that the number of carnations then is going to work out as 200 minus 50 minus 70, which is, of course, 80. So my carnations, there was 80 of them, there was 50 roses, and there was 70 daisies. So the same thing applying in every single question there. So taking your time solving the equations, this is always a good idea here, is just taking what totals do I have? What end results do I have? Because I'm going to be using everything that's given to me. So what end results do I have? I'm told that there were a total number of flowers. So can I use that in some way? So my first equation is probably going to revolve around the number of flowers then. Same thing then with the price. If I'm told the total amount of money that I made, then I'm probably going to have an equation that revolves around that. And then our last equation in these 3 variable ones is often just one relating to 2 variables, and how do they kind of interact with each other. But yeah, so they're definitely ones that take a little bit of practice and just in terms of really working out exactly what's happening at each stage. But there is kind of a general formula or methodology happening there in each of those ones that we've looked at, I suppose.